Air Products has 25 years of experience in the electronics assembly industry. We supply a unique portfolio of atmospheric gases, process and specialty gases, performance materials, equipment, and services. We strive to understand your business, and we are committed to helping you with process improvements that can contribute to defect reduction, improved process uptime, and an overall improvement in your cost of ownership. We would like to share with you results from our recent study, which focused on preventing the formation of head-in-pillow, or HIP, defects in the electronic assembly process using an inert nitrogen atmosphere reflow. A head-in-pillow defect is an incomplete coalescence of the solder ball of a surface mount component and printed solder paste upon reflow. The defect got the name of head-in-pillow because when looking at the cross-section of a solder joint, it looks like a head is lying on a soft pillow. What this means is that head-in-pillow joints only connect through mechanical contact, creating possible electrical discontinuity and compromising the reliability of the electronic device. HIP defects are becoming even more of an issue when it comes to reliability because of the increasing market and technological challenges associated with RoHS compliance and increased assembly functionality and miniaturization. Smaller size devices increase the chance of oxidation at the solder ball surface and in the solder paste, or at the board pad finishes. This metal surface oxidation is one key factor contributing to the formation of HIP defects. These defects typically occur due to poor wetting or warping of the component upon heating, which prevents metallurgical contact. While current industry trends tend to prioritize solder paste or flux dipping processes and the use of solder paste flux formulations with a higher metal oxide reducing potential, we took a slightly different approach. As a leading industrial gases company, one of our strengths is inert atmospheres, and specifically nitrogen atmospheres, which are effective in preventing the formation of metal surface oxidation during reflow and ensuring better solder joint formation. In this most convincing graphic presented by Alpha, one of the world's leading material suppliers to the electronic assembly process, the effect of reflowing components under an inert nitrogen atmosphere shows the dramatic decrease in head-in-pillow defects as compared to a traditional air reflow process. We designed an experiment that visually demonstrates the benefits of using nitrogen reflow on the reduction of HIP defects and the improvement of the assembly reliability and inline productivity. Air and nitrogen reflow experiments were conducted at Intertech using the convection oven of a rheometer for its inerting capability and straightforward temperature control. This setup was designed to accurately simulate the conditions used during a conventional oven reflow process. First, the solder printing process was performed on a custom-made stencil printer using a pre-cut piece of board and a lead-free, no-clean solder paste. The components tested were a 0.8 mm pitch ball grid array and a 0.5 mm pitch chip scale package. A custom-made sample holder was designed to hold the piece of board, and an alignment mask was created to facilitate the alignment of the component balls to the board pads using alignment pins. The board is clipped to the sample holder. The alignment mask is then clipped on top of the printed board, and the component is aligned using a vacuum pen. Once the component is carefully aligned, the alignment mask is removed and the sample holder is placed into the chamber. We used a soak temperature profile recommended by the solder paste manufacturer for BGA and CSP components to minimize void formation. All nitrogen reflow experiments were conducted at about a 1400 ppm oxygen level. Now, let's look at the results. These comparative videos show the effectiveness of reflowing a 0.8 mm pitch BGA component under a nitrogen atmosphere as compared to a conventional air reflow. Reflowing under nitrogen results in faster formation of cleaner solder joints with no or few HIP defects, providing improved assembly reliability and inline productivity. Similar results were obtained when reflowing a smaller pitch size CSP component under nitrogen. This showed improved wetting and also facilitated the self-alignment of poorly aligned components upon reflow. The use of a reduced oxygen environment during the reflow process of BGA and CSP components with a low-activity rosin-based paste demonstrated better wetting performance than under an air reflow environment. Nitrogen reflow prevented the formation of new oxides while avoiding the use of solder paste with high fluxing capacity, providing improved wetting performance, reduced amount of HIP defects, and improved quality and cleanliness of the solder joints. For more information, please call 800-654-4567 or visit us at airproducts.com/electronics_assembly.